Variance of the sum of two variables, Part 2. Recall that when the variables x and y are independent, the variance of the sum of x and y is the variance of x plus the variance of y. The variance of x minus y is also the variance of x plus the variance of y. When x and y are correlated, the same formula is used with an additional expression included that accounts of the relationship between the two variables. This expression is the correlation between the two variables, expressed with the symbol rho times the variance of x times the variance of y. So, when the variables are correlated, the variance of x plus y is the variance of x plus the variance of y, plus 2 times rho times the standard deviation of x times the standard deviation of y. Or, the variance of x minus y is the variance of x plus the variance of y minus 2 times rho times the standard deviation of x times the standard deviation of y. For example, let's examine how we could calculate the variance of the sum or the difference between the verbal and the quantitative scores on the SAT. Assume that the variance for verbal SAT scores is 10,000 and the variance for quantitative SAT scores is 11,000. Also, assume that the correlation between these two tests is 0.5. The calculation of the variance of total SAT scores is shown here. It is equal to 31,488. The formula for the difference between verbal and quantitative SAT is the same as the formula for the sum, except that the third term is subtracted instead of added. The variance of the difference for this example is equal to 10,512. If the variance and the correlation are computed in a sample, then the same formula is used with a different notation to express the variances, correlation, and standard deviations.